All right, hello everybody. Let's go ahead and get started. Some reminders before we begin today's topic. You have an assignment due tonight, so homework 1 is due this evening by the end of the day. I checked before class. It looked like a lot of you are already done with at least the part that required you to get onto the shell server, so that was good. If you haven't done that yet, you got a little bit more time to finish it up. Homework assignment 2 is out now. It's already posted, and I plan to talk about that for a few minutes at the end of class today, so we'll have a chat about that a little bit later. Also, I've updated office hours, so I just want to make sure you're aware that I am still continuing to add office hours, and actually I added some for today. I was able to clear it out so that I can have office hours on Wednesdays, so now we've got office hours almost every single day of the week, which is fantastic. So if you have any last minute questions about the assignment, or you want to get a jump start on the next assignment, I'll be in my office today from 2 to 4 in the afternoon. Swing by and say hi, and we can talk about the assignment. I'm trying to think if there's anything else coming down the road that you need to be aware of. I think that's it for right now. Any questions that I can answer about the assignment that's due tonight, or any other stuff regarding the calendar scheduling before we hop in? All right, cool. Well, then if I forget, somebody please remind me. I do want to spend 5 or so minutes at least at the end talking about the next homework assignment, so don't let me forget to do that before we leave here today. Otherwise, we're going to go ahead and get started on today's material, which is about scripting. So we have spent a lot of time learning how to use this, learning how to use the command line. And today we're going to see, we're going to tie together everything that we've been doing up until this point. We're going to write some scripts that help us do basically whatever we want. Scripts are a way to help us automate tasks that we need to perform. So all of the commands that we have been learning about are going to help us perform these tasks. So really a script then is just a list of commands that you want to be executed in a particular order, just like much like a program. The main difference between writing the scripts that we're going to talk about in class versus the Java programs or other programs that you've been writing in your other classes are that scripts are going to be more focused on manipulating files, directories, right, that kind of thing. Whereas your Java programs can do many different things outside of the realm of what typical bash scripting can do. So I'm going to go ahead and get started with a very simple hello world program. I encourage you to follow along with me today. I'm going to type up probably 10 or a dozen small little scripts. I'm going to ask you to write some scripts today as well. So the first thing I'm going to do, I'm in a directory, and if I do an ls, you'll see that there's nothing in it. So I'm just in a brand new directory that I created before class for today's stuff. And I'm going to create a new file. I'm going to call it hello world.sh. If you ever see .sh on the end of a file, that's your indication that you're looking at a script. You're looking at a script of some sort. So I'm going to open this up, and this file doesn't exist. It's a brand new file, so of course it's blank. And in order to make a script, the first thing that we need to do is include a little directive up at the top of the file that says, hey, this is intended to be run as a script. And so I'm going to go directly into insert mode by hitting the I key, little refresher, and I'm going to type in the directive, pound exclamation point is how you know that we're working with a directive, and then /bin/bash. This is saying, I want you to execute the rest of this stuff in bash. That's what that line is saying, right? It's a directive to the operating system that I expect you to execute the rest of this code in bash. So this is going to be at the top of every single script file that we write today. Yeah. Kind of hard to see. I can try to blow the text up a little bit more. Maybe that would help. It's probably the color actually that makes it hard to see. How do I change that? Oh no. Screen text. Yeah, I don't know how to change the blue. I mean, I don't want to spend the time screwing around figuring out how to change the blue text. Here's what I can do, maybe at least temporarily. Does that help, or does that make it worse? Does that make it easier or harder to read if I highlight it? I could also maybe switch this to a light theme instead of a dark theme. I could switch the background to be like a grayish color. Whoa. Purple? Oh. Oh no. That was a poor choice. I'm sorry. That'll be too light. Blue? But that's blue on blue then, so that's not gonna work either. That's just invisible. Yeah, sorry. All right, I need to stop messing around with this. Yeah. Okay. There's the directive, /bin/bash with a pound exclamation point up top. After you have that directive in, you can type any bash commands that you want afterwards. So the bash command that I'm going to type for this very simple program is echo hello world. This is about as simple a bash script as it gets, and thankfully that text is not blue. You should be able to read that brown and red text hopefully much better than the blue up at the top. And so we know what the echo command is. That's actually the first command that I showed you. Yeah, question?
Sorry, can you repeat that very first line one more time?
The directive up top. Pound exclamation point /bin/bash.
Did you write it like in insert mode?
I did, yes. Yes, I am in fact in insert mode currently. So this is our very simple, very basic introduction to bash scripting. I've got a directive up top, /bin/bash, and then a command, echo hello world. How do I get out of Vim? How do I tell it to save and quit? :WQ. Oh. Oh, okay. All right. Escape to get out of insert mode, and then :WQ for write and quit. And now if I look at my files, you'll see that I actually have this script hello world.sh. Actually, I want to see the permissions of this really quickly. Right? Hello world.sh. And so I want to run it. I want to run this script now. And you might think that the intuitive way of doing that would be typing the name of the script and hitting return. And when I do that, it says, I don't know what you're talking about. I have no idea what it is that you're talking about. And it's like, well, hey, dummy, it's right here, right? Like, what do you mean you don't know what this is? There's a little bit of additional syntax that we need to provide. If I'm accessing a file that's in the directory that I am currently in, we need to put a dot. Dot means here, right? Dot means where I currently am, / hello world.sh. Now I can properly locate the script and it executes it, which just prints out a simple hello world message to the screen. So this is our very first script. If this line didn't work, if your ./hello world line didn't work, then chances are there might be something up with your permissions. So recall permissions. There's 3 of them: read, write, and execute. And right now, this file's got all of them, right? This file's got a whole fistful of permissions. But if you don't have execute permissions, so if this was read only, I'm sorry. Whoops. If this file had Whoops, that's still got execute on it. I think my I think my terminal is trying to help me out here by making sure my script file is in fact executable. I can't force it to not be. That's interesting. Yeah, it won't let me make it not executable. Well, anyway, if you don't see that it's executable here, then you won't be able to run it. You won't be able to execute that script, so you'll have to change the permissions accordingly to make sure that you can actually run that script. So permissions are important. My computer is forcing this file to have executable permissions because I told it was a shell script. That's not always true. Depending on how your system is set up, that may not be true. You may have to alter the permissions of that file to get it to work. All right, any questions so far? That was the basics. We're gonna do some more complicated stuff now. So I'm gonna make another script file. I'll call this one variable.sh. Show you how we can create variables in our bash scripts. All right. I'm going to type the same thing at the top that I did at the top of the last file. Pound exclamation point, that's the directive, /bin/bash. That's going to go at the top of every single script file that we're writing today. And now I'm going to create a little variable. I'm going to create a variable, and I'll just say, I don't know, output equals, and then I can specify a string here if I want to, you know, whatever I want. I have now created a variable called output, and the contents of that variable is the string hello. So that's a string variable. Notice that unlike Java, I didn't have to tell it that it was a string. It just assumed based on the quotation marks that I've included that this is in fact a string, right? So the idea of specifying a type, it's not relevant here. It's going to figure it out. And then if I want to use that variable with an echo command perhaps, in order to access a variable, we put a $sign out in front of it. Is that purple text readable? Or is that also hard to read? Also what? Also difficult? Whoops, oh no. Sorry. What did I do? Output equals hello, echo, $sign, output. I was gonna see if I could switch the background. Oh, there we go. That's a little better, right? A little blinding, but at least you can read the text easier now, hopefully. I hope. So to create a variable, oh, you can't see the equal sign. That's a problem. Man, I just can't win today. No good colors for this. Oh, no, no, no. All right, sorry, I need to stop. Let's stick with black. In order to create a variable, you just type the name of the variable followed by an equal sign. In order to use the variable, you have to put a $sign out in front to access that variable. Yeah, question?
Is everything case sensitive?
Is everything case sensitive? I believe that it is. If I use the wrong letter T here, let's find out. We can run this script and see. Yeah, so it didn't find it. It printed out nothing. It didn't error though. It didn't get mad. It just said, oh, okay, I tried to look for that variable you told me about. It didn't exist, so I'm not going to do anything, right? So the names of the variables, and actually convention states that bash variables are usually in all caps. It doesn't require you to do that. If you use lowercase for your variables, nobody's going to complain. Bash isn't going to complain. But convention typically states that bash variables are uppercase. And so if I run this, there it found the variable and printed it out, right? Printed out the text. Okay? Question in the back.
What did you do to make it?
He asked if they were case sensitive, so I switched, some of these and made them lowercase, and it didn't work. So then I switched them back to be uppercase to match the case of the declaration of the variable. Yeah. So what's interesting is that I can combine commands together, or I can actually save the result of a command into a variable if I want to. So here's an example of what that might look like. Now these little guys here on either side of the ls, I know those are going to be a little tricky for you to see. Those are backticks. That's way up in the top left corner of your keyboard. It's called a backtick. It's not an apostrophe. It is not an apostrophe. I know that it probably kind of looks like an apostrophe from where you're sitting. Maybe I can blow the font up. That's something that should be easy to do at least. Let's try bigger font. That should help a little bit, maybe? I don't know. Those are backticks. Make it real big. Make it giant.
That's so much better.
Oh, good. Glad to hear it. So your backtick key is up in the top left corner, usually right by your escape key. So if I do this now and I run this program, yep, that's what I was afraid of. It's too big for my... Okay. It ran the ls command and displayed the output of that ls command. Ran the ls command, put it in a variable, and then printed out the contents of that variable, which is just the output of the ls command, right? So I've taken the output of a bash command, stored it in a variable, and then I can do stuff with it later. Of course, I could also leave the variable out of this entirely if I wanted to, and just do a bash script that says, ls, right? Like bringing a variable into it is not necessary. I could just do ls and have it run ls, or I could just type ls in the command line, right? I'm trying to show you the various techniques that we can use in our bash scripts. Okay. Next technique to talk about is how to do arithmetic operations. So I'm going to create a new file called arithmetic's a difficult word, so I'm going to call it math. That /bin/bash. In order to do arithmetic, you have to have parens. And not just one paren, but two of them. Two parens is your signal to bash that, hey, I'm about to do some math here. I'm about to add some stuff or subtract some stuff. And you can use variables. So this will, and you can see VI is matching the parens for us. That's kind of nice, right? So what do I want to happen? I want to add 237 and 131 together, store that in a variable called sum, and then, just to verify that things are working the way we expect, I can print out that sum variable, right? But in order to do that math, I have to include double parens around it. And there is what I assume the sum of those two numbers is. Any questions on that one? That one's pretty straightforward. Just got to remember the double parens. I'm going to show you one more little technique, and then we'll do an exercise. User input. If I want my user to type something in, and I want to be able to use that as part of the script, that's something that we can do as well. So let's make a script called input.sh. And surprise, surprise, I'm going to put the directive up top, /bin/bash. I'm going to type out a little message that says, enter your name, right? So that they know what I want them to type in. And then in order to grab user input, I'm going to use the read command. read name is going to take whatever they type in and put it in a variable called name. Called name. And then we can print out a little message. Pay attention to what's going on here. I've done string concatenation, right? I've done string concatenation on that last line. You can tell from the highlighting that it recognizes $name as a variable, even though it's inside of the quotes. That's very unlike what you would see in Java, for example, right? Java wouldn't want to do that. You'd need to use the plus sign to tack variables onto a string. But Bash doesn't care. If I use that $sign in front of a variable name, it'll pick that up. It'll pick that up and use it and concatenate those values together. And so if I run input.sh, now it's sitting here, it says enter your name. It's waiting. It's waiting for me to type something in and hit return or enter. So I'll type in my name and it says hello to me, and then it quits. The script's over. The script is done. Any questions? Any questions at all? Next up on our agenda is a little exercise using these techniques. Any questions? Let me pull up the first exercise then for today. All right. I want you to create a script that's going to do the following. I know this probably sounds a little complicated, but it's actually a fairly straightforward process. Don't overthink this problem. I've guinea pigged this on a few people and noticed that people were kind of overthinking the problem a little bit. Don't overthink the problem. First step is prompt the user to enter the name of a directory, a folder that they want to create. We will create that directory. That should probably be step 2, actually. Create the directory. And then step 3 is to go into the directory. So real quick, to kind of give you some help here, the command to get user input is read. How do I create directories in Bash? mkdir. How do I navigate into a directory? cd. How do I print out the path? pwd. Good. pwd. Return to the original directory. What's that going to be? cd. And then delete the directory, or rm, however you want to do it. See if you can put this into a script and make it work. Take a few minutes, talk to your neighbors if you need to. Do a little collaboration. I'll give you a 5 to 10, and then we'll piece this one together, okay? And don't forget the directive in Bash. Yeah, what's that? There's only one that I know of, and it's way back. It's already surrounded by a lot of so with your odds of staying there. There's one outlet. What's up? That looks like the output of LS to me. So did you make a variable that stores the result of ls?
I mean, you can just tell us that.
So you're calling ls. So then we're working out the variable. So what you're looking at is the output of ls. Since that's what you store the variable.
Oh, permission denied.
Uh-oh.
Check the permission. I need it. 75576.
I think it's 755. As long as you say.
I'm not sure. He said I'm in my office.
Oh, you gotta say the name of the. Well, you should run it. Did you run it? No, because it's supposed to prompt you for the name of the directory.
Oh, was that? Oh, okay. Is that what the what you're doing? Oh. Yeah,
Oh, okay. So when you run it, you have to because you're reading.
Yeah, I did.
Oh, you typed it in?
Yeah, I was saying
Yeah, you
set number escalators. Yeah, that's like
maybe I take away the L.
oh wait,
Well, you can still do that.
wait, what? Isn't that the person?
Yeah. So what I did is like my last line, which was the remove directory thing. That's what after I finished the script.
I accidentally deleted the town, that's why.
But yeah, just
So you have to call echo and then you redirect it. One line at a time.
Yeah, okay, cool. Yeah, I'm saying, you have the RBIR.
All right. Let's take a crack at this. I saw a lot of people doing some cool stuff, so let's piece this one together. I'm gonna make a script. I'm gonna call it exercise 1, I guess, because I'm unoriginal right now. And the first thing was to prompt the user to enter in the name of a directory that they want to create. Whenever I'm prompting the user for stuff, I think it's smart to, give them an actual thing to do so that they know what you are expecting. So I like to put a little echo statement out front, and then I can do what we talked about earlier, which is the read command. So then I can do the read command and give it a variable name. So I don't know, dir name is as good as any other. All right. Step 2 then is to create that directory. And so we said before that it's the make directory command and then something like that, right? I need the $sign. This is one of the more common things that I see. Recognizing the fact that when you create a variable, you don't need the $sign, but when you use a variable, you do need the $sign. That's something that tends to throw people a little bit when they first get started writing these scripts. So I can plug that variable name directly into the make directory command, and it'll do exactly what you think it'll do. It'll make the directory with whatever contents inside of that variable. Okay. Step 3 then was to go into the directory that was created. So that's going to be a very similar command, right? cd directory name. Then, print out the path to the directory that was created. So we said that's the pwd command. What arguments do we need? None, I don't think, right? pwd by itself should do the job. Then I want to go back to where I came from. How do I go back to the prior directory? cd ... takes me back to the prior directory that I was in. And then finally I want to delete the directory, so I'll call remove directory on dir name. I forgot one very important thing up at the top. Forgot that directive. Pound !! /bin / bash. I think this will do it, but we should give it a try. Yeah, what's up?
Does cd ... bring you back to the previous directory, or does it move you up one level?
Up one level in the tree, yeah. So yeah, it's an important distinction. It's not like a stack. It's more like a tree. It moves you up to the parent directory. That's a better way of describing it. Yeah. Or another way of thinking about it. If I look at this, right? If I type cd ... this is where I am now. cd ... is going to take me here, right? It'll always take me to whatever the prior element is in my current path. All right, let's give this a try. Exercise 1. Enter the name of a directory to create. I don't know. Hi. So created the directory, printed out the path to it. You can see there's the word hi down at the end. And then if I do an ls, I can see that it did in fact delete the directory. Right? Did in fact delete the directory. So there's no trace that it ever existed. The only reason that we know that it existed is because we can see it in the output of pwd there as a result of our script. Are there any questions about that exercise? Yeah, what's up?
So you don't need the tick commands when you want to connect?
Yeah, that's a good question. I'm glad you asked that. When do we need the backtick commands? We need the backtick commands if we're saving the output of a command to a variable. If I just want to execute the command, I just type the name of the command that I want to execute and it'll run. If I want to save the output to a variable, then I put variable name equals, and then I have to use backticks around the command. So we only need to bring backticks into it if we are using variables? Good question. Good question. Any other questions about this before we take a look at some other stuff that we can do with bash scripting? Any other questions? All right, fantastic. Let's take a look at some more cool stuff then. First thing that we're going to take a look at now is loops. Let's do some loops. Loop1.sh. I'm going to show you a couple different types of loops. I know you're all familiar with the concept of loops from prior classes. So I'm just going to show you kind of the bash way of using loops to do things. These examples maybe aren't the most practical examples in the world, but I almost always am going to use this style of loop in bash for variable name in. It's a for each loop, if you're familiar with that concept from Java or from other languages. I'm almost always going to use a for each style loop in bash. You actually can write a loop in bash that looks very similar to a loop that you would write in C or Java, with the parentheses, counter equals 1, counter less than, whatever, counter plus plus. You actually can write loops like that in bash if you want to. Very rarely do I find myself in that position because there's a nice little piece of syntax that we can use here, right? And this does exactly what you think it does. For counter in 1 to 10. Start at 1, count up to 10. The dot dot in the middle, exactly 2 dots. 3 is too many, 1's not enough, right? 2 dots is that range operator, so that's what will generate. It actually generates an array of elements from 1 to 10, and then the loop will iterate over each one of those. And for this very simple example, we can just do, we just print out the counter. There is a do, so notice I use curly brackets up top for the range indicator, so I can't really use curly brackets to start and end my loop. Bash will not interpret that the way that Java does, right? As the beginning and the ending of my loop. So the way that bash does it is there's a do statement at the beginning of the loop, and then there's another statement at the end of the loop that we'll see in just a moment. I do still like to use proper indentation. The indentation on my editor is apparently set to like 8 characters, which is a little extreme, but still does the job, I suppose. And so I'll just do a simple, we haven't seen this argument before, -n. We're about to see what it does. I don't think you'll have much problem figuring it out. So I'm just going to print out the counter, and then once I'm finished with my loop, I'll type done. So do to start the loop, done to end it. The indentation does not actually matter here, other than it makes it easier for us to read, which is important. I encourage you to use it for that reason. Bash is not going to force you to indent stuff. All right, let's try it out. I mean, this should do basically what you would expect it to do if I type this out. Can you tell what that -n did with the echo? Can you tell what the difference is between using echo with and without the -n? Creates a new line, yeah? It wants to create a new line. So if I don't use -n, it's going to put a new line at the end. If I do use -n, it's saying don't move to the next line, just keep everything. It's a difference between print and println in Java, right? That -n flag. And so it did exactly what you would have expected. It printed out the variables. I think what's more interesting about these loops, so if I do another simple loop example real quickly, if I want to do something like this, for n in 1, 2, 3. Now this is a string, right? I see the quotes. That's a string. But take a peek at what happens when you, code up a, whoops, I forgot my do, done. Another very simple for each loop. Anybody, what do you think is going to happen when I run this? In Java or some other language like Python, what would happen? Would it even accept something like this? It might say, I don't know what you're talking about right now. Get out of here with that. Let's run it and see. It actually treated the entire string as one piece. And so that's probably not what we wanted to happen, right? We wanted it to probably be maybe one word at a time. But I think with a little tweak here, we can probably, will the commas do it? Actually, no, the commas don't do it. What is the, I'm drawing a blank on the syntax. I might have to look it up real quick. Hang on, let me look it up. For each string. String values. Oh, you need parentheses. That's what well, that's more complicated than I thought it was going to be, though. I mean, interesting. Okay. This is yeah, comma to separate the string values. Interesting. All right, this example is not going the direction that I intended, but that's okay. These things happen. My fault. My bad. Well, there certainly are ways to split this up. I think maybe it was hard to tell from the page since the text is so small, but Bash does do things like arrays. Here's an example of a string array. I wasn't intending to talk about arrays today, but you know, since I'm staring at the page, might as well mention that yeah, arrays are a thing that exist. I wasn't intending to use them in this particular example. It just so happened that I stumbled upon them, but you can see that they work similarly to how you would expect Java arrays to work with the bracket notation, but you've got this strange little @ syntax in there. That strange little @ syntax. For the homework assignment, you shouldn't need the use of arrays, so I'm not going to spend much more time dwelling on it than just bringing them to your general attention. Anyway, so that kind of busted. Oh well. What else did I want to show you? Let's look at if statements. Let's throw this one in the garbage. Bye. You were a bad example. And let's do if statements. If statements kind of have two categories. If the condition that you're checking is based on arithmetic, you're going to do it one way. If the condition that you're checking is based on non-arithmetic, I guess, for lack of a better term, you'll do it a slightly different way. So let me show you an example of both formats. If math, we'll do an arithmetic example first. So the first thing that we need is a number. I'm just going to hard code one in. It's a little boring, but I want to do some arithmetic comparison. So I'm just going to hard code in a variable for starters. And then we can start doing some if work on it. Remember, arithmetic we've seen before uses double parens. So that's going to be the same here as well. If n is less than 10. Does exactly what you think it does. Notice that I was very careful about spacing here, about putting extra spaces in between the operators. Bash is notoriously finicky. If you don't leave proper spacing in between the operators, it'll think it's all one big piece and it won't interpret it the way that you intended. I think it's always, always, always better to be safe than sorry and leave yourself a little space in between each piece of your expression. because you never know when that fun little syntax stuff is going to happen. So, you know, if n is less than 10, then echo less than 10. Right? If I want to do additional conditions, there's an elif, short for else if, and then I can stick another condition here. If n is greater than 10, or I could have done equal to as well. So the comparison operators work exactly the way that you think that they do. Greater than 10. Echo greater than 10. Oh, I'm missing a then. And then finally I can do an else, echo equals 10. I don't know why I switched between the numerals and the words. We're still not done, actually. There's one final piece. How does it know when the else is finished? The answer is it doesn't. It doesn't know when the else is finished. Remember, we don't have curly braces to tell it the beginning and the ending of blocks. So to end an if statement, we have to remember to put this little phi or phi or whatever, however you want to pronounce it, tag at the end of our if statement to indicate that, all right, our if statement is now over. And if you wanted to do some proper indentation here just to make it a little bit easier to read, you might do something like this. Everybody with me? Question?
So for the else statement, do you still have to put a then, or is it?
You do not need a then, actually, for the else statement. Yeah, that's a good question. It's not required for the else, only for the if and the else if. Yeah. And so you can try this with, you know, changing n to various numbers. It's not an exciting script, of course. Equals 10, surprise, surprise. But if you change it to be some other stuff, then it's 9 now, so it tells me it's less than 10. I can make it a number larger than 10. It would do the same thing, right? Do the same thing. Now, in that example, I was doing comparisons with numbers, with arithmetic. If I'm doing non-arithmetic types of comparisons, strings, for example, I'm comparing strings. The if statements look a little bit different. So let's look at one. And actually, it's a little misleading to say that it's numbers and strings. It's actually if statements for numbers and then if statements for not numbers, right? So it doesn't have to be strings. It could be other kinds of things that you're checking as well. But let's take a quick look at how to do string comparison, for example. Start with my directive up top, bin bash. And then I'm gonna do, I'm gonna prompt the user for their name. And now I'll do a comparison with a string. In order to do that, instead of using double parens, I'm gonna use double square brackets instead. Double square brackets. So I wanna know if name is equal to my name. And I'll just say, hello, right? I could have used the variable here, whatever, it doesn't matter. Else, echo, I don't know you, I don't talk to strangers. I don't know. Stranger danger. Notice that double equals actually does work with strings. It's not the whole Java thing where you have to worry about the double equals versus dot equals. You know, we're not dealing with objects here, right? Not once today have I mentioned the concept of an object or a reference. It's not relevant to us. Use double equals for equality. It does what you think it does. So if I try this out, I did a typo. All right, actually, I'm glad this happened though. So here's something that happened. It's a little strange actually. I ran the script. It says I don't know what you're talking about, and then it looks like it's proceeding with the script anyway. That's interesting. On your computer, it may not have done that. It may just have straight crashed. But I'm actually at a point now where I just want to abort. I want to get out, right? Like something bad happened. I want to fix it. I don't want to keep going. I want to stop. If you're ever running a command on the command line and you get stuck, you can't type in another command, right? You need to get out of there. Control C on a Windows machine, or the equivalent, I guess, would be Command C on a Mac, is stop doing whatever you're doing. Just get me the heck out of this command. Bring me back to a prompt, right? That's a very good technique for you to know if you ever get stuck somewhere. Control C is the get me out of here button. Let me fix my directive up top since I typed it in incorrectly. All right. If I type in Doug, it says it knows who I am. If I type in anything else, it says I don't know you. So string comparison examples work. Any questions? It's a little bit annoying to have to remember those two different types of comparisons, one for arithmetic, one for string. And I'm waiting for somebody to ask me the question, what if I want to do both at the same time, right? What if I want to do strings and arithmetic at the same time? The good news is that you can do that. An example of what that, whoops, I didn't mean to run it. I meant to edit it. If you need to do both, typically that would be separated by an and or an or statement, correct? Ands and ors are still things, so I can type in and inside of the square brackets, and then I can actually put arithmetic, right, 3 is greater than 2, inside of those square brackets. And I believe this will still, I believe that syntax is correct. My syntax might be a little off. Let me see. Yeah. So I can actually embed arithmetic expressions inside of the square brackets if I need to do both. Combine those together as a conjunction. Any questions about that? Next up on our list, we've got another little exercise with loops and if statements. So let me pull that up next. Scripting, exercise 2. I'm going to ask you to write a script that asks the user to type in 10 numbers, and for each number that they type in, you're going to see if it's greater than 5 or less than 5, or I guess I should strictly greater. Yeah, strictly greater. If it's greater than 5, I'm going to keep a running sum, right? If it's less than or equal to 5, I'm going to ignore it. I'm not going to do anything, right? Just going to chuck it out. Make sense? This is, the conceptual level. This is 131 introduction to loops stuff, but I want you to get used to the syntax. I want you to get used to the bash style of doing these things. So take a few minutes, talk to your neighbors if you need to, and see if you can code up this little script, and we'll do it together in a little bit.
Hey, what's up?
sure why you're running SH when you got slash. Okay, so mine is just no need to change there. Here you go. I think if you're a different fan, it's going to have a different effect on your output.
Oh, I know. Done.
Yeah, what's
I
that?
don't think I needed arithmetic for string, y exam for string, and then.
No, I think you just tack it all inside your quotes and it's smart enough to do any conversions. It should be. All right. Is this thing working? Hello? Shoot. Hello? Test? All right, the batteries in the mic died, so I'm just going to have to talk very loudly. I do want to keep moving because I'm trying to be conscious of how much time we got left. Let's see if we can piece this one together real quickly here. I'm going to make a script called Exercise 2. Again, conceptually, I don't think this is too tricky. I'm probably going to want to create a variable to keep track of my sum, right? And somebody was actually asking me about this just a moment ago. You'll notice actually when you type, I was talking about how you should probably keep spaces in between stuff, and then Of course, there's always a counterexample, and this is it. When you create variables, it really doesn't want space in between the variable name and the equal sign. You can see it's changing the color of the variable name based on where the position of the equal sign is. So this is the one exception to that rule where the equal sign actually does need to be right up next to that variable name, which is great. Great thing to have to remember, but you'll get used to it. Put my directive up here. And then we can stick in our loop next, probably, right? So for I in 1 to 10 is fine. What's next? What am I doing next? Do? Oh, yeah. What's next after that? I'm sorry? Echo? So type in a number, probably. Type in a number, and then we want to do a read. Okay. And now we need to stick in an if statement. So I need to check to see if this number is greater than 5 or not. And whenever you're writing an if statement, you should be asking yourself, is this a double paren style if statement or a double bracket style if statement, right? And this is a double paren style if statement, since I'm doing comparison with arithmetic. Then now I need to take this number and add it to sum, right? One thing that I think people tend to forget here is that's an arithmetic operation, adding those together. So I need the double parens here as well. And actually, the nice thing about double parens is they do recognize plus equals. So you can use that little shortcut if you want to add the number. What's next? Phi. End the if statement. If statement's done. What's next? Done. The loop's done. And then echo sum. Right? Put a little message if you want to. Whatever. Not the only way to accomplish this exercise, but I think this is at least very close. There might be some syntax stuff in there that I messed up, but I think this is pretty close. I think it's pretty close. Let's see if we can run it. See how far we get. Type in a number. All right, good. 10. Uh-oh. Yeah. Plus equals. I guess you made a liar out of me, huh? All right, fine. All right. Control C to back out of that. I thought plus equals was a thing that worked, but apparently not. So I guess we have to do it the hard way. Oh, do I not need the spaces, I wonder? Is that what I screwed up? For variable assignment? That's fun. Let me try it. If that was it, that'll be 10. Nope, still didn't work. Doesn't like plus equals. All right, fine. I guess I was a space where? Oh, really? Like that? Oh, I thought that's how I had it at first. Oh, you're right. When I'm setting variables, I don't need the dollar sign. Thank you. Yeah, you're right. When I'm assigning variables, I don't need the dollar sign. That's it. Let's try it again. There we go. Awesome. So if I type in a bunch of numbers less than 5, it's ignoring those. I'll type in 10 again. That's 2 10s that I've typed in. I'm trying to keep these numbers simple. I'll type in one more 10. 30. It works. I typed in 10 3 times. Typed in 2 a whole bunch of times. It worked. It worked. I will post all of these on Canvas after class too, by the way. Don't freak out if you missed one. I'll post them all up on Canvas or Piazza or both after class. All right. There are a couple more things I want to show you, and then I'll spend some time talking about the assignment. Actually, Everything that we're talking about from here till the end is directly applicable to the assignment. The next examples that I'm about to show you are going to be very, very useful for you on the next assignment. So you might want to put a little star next to this in your notes. We're going to talk about files. So how do we work with reading stuff out of files in scripts? Or actually, before we do that, how do we even check to see if a file exists or not? Because a lot of times I'm going to want to try to access a file, and I need to know whether that file is there. Same thing for a directory. So I'm going to make a script called exists.sh, and it's going to ask the user to type in the name of either a directory or a file, and it's going to tell you, oh, you typed in the name of a directory, or oh, you typed in the name of a file, or the thing that you typed in is not a directory or a file. It doesn't exist. That's what this script is going to do. It's a very, very, very useful script, and one that it's going to help you a lot, like I said, on the next assignment. So first thing, enter a directory or file name. Prompt the user to type in the name of a directory or a file, and then I'll read it in. We've seen this before, nothing new yet. The first thing I'm going to do is check to see if what they have typed in is a directory that currently exists. So if I say if, I'm going to use square brackets. I'm not doing math here. I'm checking to see if a directory exists. Square brackets -d. -d is the indicator that says I'm checking to see if this is a directory. Name. Then echo, this is a directory. So this is how we check to see if a directory exists or not. And we can do something similar for file existence. So elif bracket bracket -f for file. Is this a file that exists? Name bracket bracket. Then echo, this is a file. Else, so if it's not a directory or it's not a file, I don't know what it is. Those are the two categories of things that we have, right? Either it's a directory or it's a file. If it's not one of those two things, I don't know. I don't know what this is. It doesn't exist. You gave me something that does not exist. Does not exist. End the if statement with the phi at the bottom. And then we can try this out. We can give this a shot. So right now, I actually don't have any directories in here. I only have files, right? You can tell from the colors. So let me make a directory here. Folder. Now I have a bunch of files and a folder. A bunch of files and a folder. So if I run exists on this and I type in folder, that's a directory. And I would hope that it would tell me that it's a directory, right? And it does. If I type input.sh, that's a file. That's a script file. It doesn't matter what kind of file it is. It could be a script file, it could be an Excel file, it could be a movie file. It doesn't matter, right? That's a file. It recognizes that that is, in fact, a file. If I type in something that isn't real, like a bunch of garbage, I don't know what that is. It doesn't exist. It's not a directory. It's not a file. It doesn't exist. I don't know what that is, right? Any questions on that one? So using -d and -f to test for existence of directories and files. The last thing that I want to show you is how to actually read the contents of a file. So I'm going to make one final script. I'll call it file print. All it's going to do is read the contents of a file one line at a time and print them out. That's all it's going to do. So it's actually fairly short. Here's something that we haven't seen yet today, but I'm sure you know what it is. You've seen that word before, you know while. While. We've seen this word today, read, line, do. I'm making the claim that this is a sufficient enough script to read in a file, one line at a time, and print out each of those lines. It looks very short and concise. That's a good thing, right? That's a very good thing. Let's break it down. Read is a command that we've seen. It reads in input, but that input could be anything. We've been using it for user input, but we have a way of taking content from a file and feeding it into a command, right? Called redirection. We can use redirection to take the contents of a file and feed it in to a command. So if I do that, read is going to read the contents of that file. It's not going to ask the user to type anything in. It's going to say, oh, hey, you redirected a file into this program. I'm going to use that for my read instead. That is my input. So it'll read it in one line at a time, and then echo one line at a time. And so if I do file print, redirect, remember, is the angle bracket. Any file that I want, I could use a script like this one. Exists.sh, it doesn't matter. Pick a file with some stuff in it, redirect it into this script, and it prints out the entire contents one line at a time. Prints out the entire contents of that file one line at a time. Take a look at the code. The command? The redirect. So this is the script that I'm running, and this is the file that I want it to print out. I can replace this with any file that I want. It'll print it out line by line, one at a time. What happens if I don't run it with the file? What's it doing now? It's waiting for me to type stuff in. Hi. And then it just spits it back out. Right? Bye. When's it going to stop? I'm stuck. Control C, yeah. It's not going to stop until I abort. Until I say, okay, I'm done. So if I don't pass in a file, it's just going to use whatever I type in. If I redirect a file into it, it'll use that file as the input. Any questions on that? That's the last example for today. I'm going to spend the last 5 minutes having a quick chat about the homework. Yeah?
What if you were to redirect a directory into that?
A directory? Let's try it. I had a directory called folder. Read error is a directory. I figured it out. It's like, I only want files. I'm not going to take a directory. Yeah. Good question. All right. Oh, question? Yeah, absolutely. Yeah, no problem. I'm going to post these up too. As soon as I get back to my office after class, I'll put a note up so that you can use these to help you out on the next homework assignment. Let's chat about that homework assignment for a little bit to wrap up today. There's two parts. There's two parts to the homework assignment. The first part is related to Vim, getting you some Vim practice. So if you SSH into the server like you did for the prior assignment, and go to the CSE237 folder, the same one, there's everybody's stuff. But what I want to point out to you is there's a new file in here called vimexercises.txt. So what I want you to do for part 1 is make a copy of that file and put it in your folder, the same folder that you used for the last time, right? Make a copy of that file, put it in your folder, open the file up in Vim, and do the exercises. The instructions are all inside of the file. It's very, very similar to the exercises that we did in class the other day. I don't expect that to take you very long. If you were doing the exercises in class and you feel like you're kind of getting the hang of using Vim, you can have that knocked out in 15 minutes probably. The second part of the assignment is going to be a little bit trickier though. I'm going to ask you to write a script. and I was trying to think of a good problem to have you solve with a script, and then it dawned on me that I was teaching a class, and I made an assignment that had people create folders and put stuff inside of the folders, and now I actually need a way to go and check to see if the contents in those folders is correct. And I was like, wait a second, that's a bash script, right? That's a script that somebody could write, and I'm going to make all of you write it. You're going to write a script that will grade the first homework assignments. I'm not going to have you use the actual homework data, though. I made up a data set. I made up a data set with fake students in it. You can grab that on Canvas. So on the assignment page for Canvas, there's a fake data set that I want you to use for what I hope are obvious reasons. So you can grab that link here. Let me zoom in on this so you can actually see. All right, so you can grab the fake data set here. That's what I want you to use to test your script. Inside of that folder, you're going to see some files. So let me run through these real quick with the few minutes that we've got remaining. I've got it on my computer here. So you'll see a bunch of folders for the fake students in this class. And inside of these folders, well, that person didn't do the assignment, so they're not going to get a good grade. Who did do the assignment? Trent Resner did the assignment. Is a password.txt file, right? That's got stuff in it, that hopefully has the right stuff in it. There's two files that look very, this file actually is very similar to the one that you used, except instead of your Wustel keys in there, it's got the fake student's Wustel keys in there, right? So you're gonna have to find the correct answer out of this file and compare it to the answer that the student gave in their password.txt file. Okay? But not only that, there's a lot of ways that this assignment can go wrong. So some of the students, here's the full class list, right? So some of these students got everything exactly right. Some of them had some problems along the way. Some of them didn't create the password file. We saw an example of that. They didn't make the file. Some of them made the file, but has the wrong content in it. It's got the wrong stuff in it. Some of them didn't even make the folder. Like, I don't know if they dropped the class, but they just didn't even, there's no folder for Superman. I don't know, he is too busy doing other stuff, I guess. But he didn't even make a folder, right? He didn't even try. So the result of your script, I want to be a list of all the students in the class with a number that represents their grade. 3 means they made the folder, they made the file, and the content is all correct. 0 means they didn't even make the folder, right? They didn't even do it. And then the 1 and 2 is like partial credit in between. The write-up explains those grades in detail, what they all actually mean. So that's your task for the next homework assignment. You'll submit it to Canvas. And yeah, I've got office hours later this afternoon, so come by and see me if you have any questions, all right?